Okay, so in this intro to calculus, yes, this counts as a mastery check, but it's also just practice, really. And I was intending, or how I usually do this, is to help you guys in class and give you some hints because this is very different and new. But we're not seeing each other right now, so I'm gonna give you a little extra help here through a video. But also, don't hesitate to reach out or ask questions in Google Classroom. Come to office hours. I won't be available tomorrow during office hours because I'm helping with the checkout. Tomorrow being Tuesday the 19th. But I could certainly meet earlier on in the day. We could set up just a Google Meets just to talk and figure this out. So, please get the help you need. Hopefully, I'll help you a little bit in this video too. All right, so for all of these, we're looking for the same point. Okay, so we're going to look at 2 from the left and the right and what's going on at x equals 2, and 0 from the left and right. So, for instance, right here is 2, and this is 0, right? So we're going to be looking for that on every single one of these graphs here. What's happening left, what's happening right, what's happening at that value. 0, 2, so on. Okay, so for A, it's saying the little negative tells us that we want to see where it's coming from, what's happening as we approach 2 from the left, right? Because if you think about it, the negative values are over here on the left. So as we come over here and we approach 2 from the left, what is f of x approaching? What's the y approaching, right? So you want to see, we're coming from the left, and when we get to 2, and we say approaching because when we actually get there, because there's a hole, we're not actually going to arrive at 2. So that's why it's called approaching. So this value here is 1, 2, 3, right? So this point would be 2, 3. But we're never arriving at 2, so we're never arriving at 3. We're arriving at like 2.9, 2.999, and so on. But we get infinitely close, right? It's a lot of infinity in calculus. We get infinitely close to 3, so we say that we're approaching 3. Then B says, okay, well, what about when you're coming from the left, right? So the x value is still approaching 2, right? We're getting infinitely close to 2. But what's the y value supposed to be there? And of course, this is kind of weirdly placed in between 2 grid marks. I didn't do that anywhere else, but that's not a very good picture. I would normally give it to you right on a grid mark so you don't have to guess at it. So let's just call this value here 1. Okay, let's pretend instead of just hanging out over there, it actually comes down to right there. Okay. And don't worry, if you already did this one and called it 1 point something, that's totally fine. I didn't mean to be confusing like that. All right, so as we're approaching 2 from the right, the f of x, or the y value, is approaching 1. So we put in 1. Okay, and then lastly, when there's nothing next to the 2 here, then we're just saying, okay, when we're approaching 2, so from both directions. Now, if we're approaching the same y value from both directions, like for instance over here on 0, then the limit exists. But if we're approaching 2 different y values, right, because we're approaching 3 when we came in from the left, and we're approaching 1 when we came in from the right, so therefore in this case the limit does not exist. Okay, we don't have a number that we can say that it's approaching. Okay, so I don't want to do the whole worksheet for you, but I just want to clarify and hopefully explain it in a different way. So you're looking for those same points, and you would do it again for 0. You're looking for those same points throughout this front side here. Okay, in this one, we're still using the same skills. We're just trying to make sure, or I'm trying to make sure you understand the notation, right? So in this case, you're given the notation, and you're going to look at the graph and determine, well, is that true or false? So just to pick one at random, and just contact me if you need help with a specific one. Right here, I'm going to do E. Right, so I'm looking at X as X approaches 3. And since there's nothing over here saying plus or minus, that would mean that I want to look at 3 and how it's approached from either side. So first, let's find X equals 3. So there's 1, 2, 3. Okay, and we can see that from the left, it approaches 1. From the right, it approaches 2. So if we are approaching from the left and right, are we approaching 1? Well, no, that's false, right? In this case, the limit would not exist. because we're approaching two different places. As opposed to underneath it, then it says, okay, well, what about it? That's very small. Let me see. What about when it's approaching from the left? Is it approaching 1? Right, so coming back over here, from the left, is it approaching 1? Yes, from the left it's approaching 1, just not from the right, okay? All right, and then these start to get, well, I think fun, but also tricky, right? Each of these notations, once you get good at this and you start putting this together, you'll start realizing that when you look at the notation, you can already determine what physical attribute you're going to see in your graph. Okay, so let me show you what I'm thinking about here. So for instance, if I have, and we're just going to kind of plot this out on this page and pick out a whole bunch of these. If I have f of some number equals a number, right, all of these right here have to be points. They're telling you a specific point. Okay. Another thing that's very helpful, if you look through your page, find anything like that, and just say, okay, that's a point. Like for instance, I'm just quickly looking, but right here, this is a point. Okay, so if you want to pause the video and even write next to all of those when you have a point, that might help you when you get to those problems. And then another attribute that hopefully after you've done this, you'll start picking out, but if you haven't yet, anytime x is approaching infinity, right? So in this case here, we have x approaching infinity, and we have f of x approaching a number, then that means horizontal asymptote, right? Because just to draw this off to the side here, if x is approaching infinity, right? So this is the x's, they keep going infinity, infinity, going on and on and on, right? The x's are approaching infinity, and the y's are approaching a specific number, then we're going to get an asymptote like that, right? And it's going to be a horizontal asymptote. So here I'm going to have a HASI. Okay, so you could look through every one of these problems and look to see anywhere x is approaching infinity and mark it as a HASI. So pause the video and then I'm going to go through and find all those. Let's see if you can find them first. Okay, so I'm seeing some right here. I'm going to have a HASI. Let's see. Number 10. Notice that we have a whole bunch of limits and infinities, but it's only the ones where x is approaching infinity. Okay, we'll talk about when f of x is approaching infinity in just a second. So here I see a couple of HASIs. And here I see a HASI. Okay, I think that's it. I might have missed some, but I think I hopefully got them all. All right, so that's when we have a HASI. Now we have this other situation here. Here we have a point, right? This is a point. Let's actually come back to this. I want to specifically look at some more infinity situations. So for instance, over here on number 10, I have where the f of x, also known as the y, is approaching infinity. All right, so let's think about that. If I have a graph and I'm coming to 1 from the left, right? I'm coming to 1 from the left, and then the f of x is approaching infinity, then I'm getting a VASI, I'm getting a vertical asymptote. Now, vertical asymptotes occur at an x value, right? So let's just say we have some x value here. And there's a few things that can happen as you approach an asymptote. Right, here's our asymptote. It could either go up this way, right? So approaching from the left, it could go up, and then approaching from the right, it could go up. We could have it approaching from the left, it goes up, but approaching from the right, it goes down. We could have it approaching from the left, it goes down, and also down. We could have it that it's approaching from the right, going up, right? So there's things that happen on both the left and right. So a lot of times for an x value and a vertical asymptote, you're going to be told what's happening on the left and the right. Not every single time, but a lot of times you'll see that. So for instance, right here, I have some VASIs because I have the f of x approaching infinity. So I'm going to go ahead and mark that over here. And I have this positive 1, and I'm told what's happening when I approach from the right is negative infinity. And now if I look through what I have here, I'm also going to be told someplace else what occurs when I approach that positive 1 from the left. All right, here's from the left, it's approaching infinity. Okay, now if I look for this negative 1, it tells me what's happening approaching from the right, and then it's going to approach negative infinity, and then how it's approached from the left. All right, so these things here are saying the same thing, but this one is written as two separate notations, right? We have this limit, and this one's writing as one big long one, right? They could have certainly given these as something like this. It's just a different way to write it, but it's saying the same thing. Okay, so why don't you go through, pause the video, go through and see if you can find where all the VASIs are in these problems. Okay, so on number 11, I have a VASI, and I see one here on number 12. Oh, I have one over here too. Okay, so here's an example where they only told us from one side. All right, that -4 I'm not seeing any place else in these directions. So we can just have the graph end right there if we want, but I'm actually going to graph that one a little bit. Okay, then we have a bunch of other little things in here that we could go through and try to figure out. So for instance, on number 12, at f of 5, there is a removable discontinuity. Now remember, the only removable discontinuity is a hole. A jump or a VASI, like if you look on the front of the page, the jump and a VASI are non-removable. So we have the hole is removable. It says limit as x approaches 1 does not exist. That means it's coming from two different directions, right? So two different directions. Okay, so I'm just trying to give you another strategy to attack these and kind of look at what the words are saying and then translate it so that way when you go to draw the graph, you kind of have a plan of what's going on. So looking up here, at f of 3, there is a non-removable discontinuity. So this could be a jump without even doing the rest of it right now. The possibilities of this is not a hole, right? But we could have a jump or a VASI. So when we're talking about discontinuity, we're always talking about a VASI, not a horizontal asymptote. That would not cause a discontinuity. At f of -4, there is a removable. So removable is a hole. Okay, so if you're struggling with this, try that strategy to think about, okay, what's the notation saying and what am I actually going to draw, right? And then once you have that figured out, it might make it a little bit easier to plot these. I did get a request specifically on 11 and 12, so I'm going to go through those really quick and see if I can clarify. So this is a point. The limit does not exist. That means it's coming from two different directions. Okay, so one more thing that I don't think I really emphasized enough, this is a point right here. In the video is something that students mess up on is creating graphs of non-functions, right? You have to be very careful you don't have anything overlapping. All right, so now we have a game plan written out here. I know that I have a HASI, a VASI, I've got a couple of points in there, and I have a limit that does not exist, so I know that it's coming from two different directions. So let's go ahead and plot those points first because they're pretty straightforward. So -1, 0, there's a point. And we also have one at 2, 1, so 2, 1. Okay, now let's put in some dashed lines for our HASI. So I see that I have a HASI at 0 and also one at 1. So I'm going to put in a dashed line at 0. And also at 1. Okay, so I remember back when we were learning about horizontal asymptotes, it is always a surprise that you can cross a horizontal asymptote. So some people might be starting this problem going, well, I don't understand how I'm having a horizontal asymptote and also a point where y equals 0, right? But that is possible. You can cross it This HASI determines end behavior. Okay, you cannot cross a vertical asymptote because then it would not be a function, but you can cross a horizontal asymptote. This just has to do with end behavior. Okay, so we have a HASI at 0, and it's determining the end behavior. So let's draw in the end behavior, x as it approaches negative infinity. So we're going to, positive infinity. So at 0, we're approaching positive infinity. So where's my 0 asymptote? Right here. And we're approaching positive infinity. So that's really all I know right now. I'm not going to draw much more than that. I just know that it's going to be approaching that line there. And then as we approach negative infinity, it's approaching positive 1. So again, I'm just going to try to draw kind of a flattened line and then draw on the rest later on. All right, so I have a point. What else do I need? I need a VASI. So let's get that in there. Do this in the same color. Okay, so the VASI is at 0. And we're told what's happening approaching from the left and the right. When we approach from the right, we're going to positive infinity. So I'm going to draw that little arrow in there. And when we're coming from the left, we're going to negative infinity. Okay, so I have now taken care of my HASIs, my points, my VASI, and now I have my limit does not exist as I'm approaching 1. So let's find 1 and know that we need to do something so the limit does not exist. Now, when the limit doesn't exist, it can be a jump or a vertical asymptote, right? Because two things are happening from either side. It's approaching two different numbers. Because we have a VASI right next to it, I'm going to do a jump just because I just think that would be so much easier rather than trying to fit in another vertical asymptote there. Asymptote. All right, so right there, I'm going to draw a hole, and I'm going to pick a point elsewhere, also on this same X. Okay, so I'm just going to pick a point here. Whoops. My pen. My Y values for this hole and this point that I chose are completely arbitrary. Okay, it does not matter what you pick here. Okay, I'm just trying to make it so I have a jump. And the fact that I chose one to be the hole and the other one to be the point are completely arbitrary as well. The only thing that's important is that they both fall, when I'm doing this jump, that they both fall on this X value of 1. All right, so now let's try to connect all these dots here and make something that makes sense. And that's take some thinking, because you have to be careful not to create something that is not a function. So for instance, right, let me just say I'm going to connect this. This is what I see sometimes. See this. Okay, for instance, all the black here is what I've come up with. This isn't a function. This fails the vertical line test in multiple locations, right? So that's what makes these kind of hard, is you can't just go and connect the dots randomly. You have to actually make sure that when you do this, you're creating a function. So let me undo all of this and be a little more thoughtful about it. Okay, so I have this end behavior over here, right? And I drew it in above, and now that I'm looking at the rest of my graph, I could certainly approach it from below, right? The important thing is that it's just approaching 1. Go through this point and go down. That would get rid of this up here. There we go. There's one way this can be done, right? You could also say that, yes, it was still coming from above, it's approaching, but now it's going up and then down. That's another way you could do this. So I'm just showing you how there's multiple ways that you're going to come up with your actual drawing here. But the important thing is that you just hit all the parameters. So I'm still approaching 1 as the x's approach negative infinity. I'm still hitting that point, and I'm still aligning with that vertical asymptote. All right, so now let's go and do the other side here. So the important thing is that I have this vertical asymptote, right? That I hit this hole that I made, that I have this. Okay, so I'm seeing an issue. right? As if I do this, and then I have this point here, well, how am I going to connect all this? Right, now keep in mind that this point down here that I created was totally arbitrary. I could put this anywhere. I just don't want it to have it. I just don't want to connect right up with that hole. And that's going to happen, right? You're going to draw things and realize, oh, that doesn't really make sense. Okay, so you'll have to change it, and it's challenging. So I made this point, and you have to remember which points were required and which you came up with. But I came up with this point. It wasn't required. So I'm going to actually move that point. And I'm going to, instead, I'm just going to draw it in. But I'm going to say, all right, I need to approach this asymptote, this horizontal asymptote, at 0. And now I can approach it from above or below. And I had it approaching from below, but we could certainly do it from above. Sometimes you have to make those changes. Right, just like that. And then I need to make sure that my line, so we're passing through this point, that my function does actually come up to the x value of 1. So let's do it right there. But that there's a jump. All right, so that was pretty complicated, but you know, that's what this is higher level thinking here. Okay, it wasn't my intention to make this super long video, but being that I'm not around you guys, I'm not really sure how to get the information to you. So I'm going to do this problem as well. It's of course optional to watch this. I would definitely try to attempt this on your own and then watch me do it and see if you did it right. All right, so I can see I did not write this out, but I do have a point here. All right, so I have a game plan for everything, all this notation. So let's go ahead and plot some of these parts. So I have -3, 0 is a point. So -3, 0, I'm going to draw a red point there to match my notation, -3, 0. I have a point, I'm going to make this red also. At 0, 3, so 0, 1, 2, 3 is a point. I have a hole, right? And a hole that's not part of a jump, but an actual hole. There is a removable discontinuity at f equals 5. Now, notice it doesn't tell us where along 5 that hole has to be. So 1, 2, 3, 4, 5. Somewhere along here, I'm going to have a hole. So right now I'm just going to draw a random hole in. I might have to move that based on where the rest of my graph ends up. I have a Hasse at -1. Put that in blue. -1. We're going to, this again is just going to tell me my end behavior. And based on how the other one came together, I'm not going to draw in that end behavior yet. Just know that I have a Hasse there. I have a Vasse at -2. So I'm going to grab the green here, go to -2, draw in the dashed line for the Vasse, -2. Okay, so we're approaching the left and the right. This one I think it's easier to actually draw in this behavior here. So left and right, we're approaching infinity. So coming from the left and the right to -2, it's going to look like this. Okay, then we also have one at -4. And we're only told what's happening from the right, that it's approaching infinity. Okay, so I'm picturing like a little U shape here, and I see that I have a point there. I'm going to go ahead and draw this part in because there's not a whole lot of options here. Right? It's got to go like this. It's got to hit that point. I mean, there's other things that could happen, but it's kind of a small space to draw some stuff in. So what else do I need on here? I have the hole. I did all of this, and this, and this, and this. I've marked out that I'm going to put a hole someplace, and the limit does not exist at 1. So we need to come in from 2 different directions here at 1. All right, so let's start thinking about this. All right, so over here on this Hasse, let's see as it approaches -infinity if we have any information. I'm not seeing any information about approaching -infinity, only information about approaching positive infinity. Also, I see that I have an asymptote here. Right, so I could draw something over here if I wanted to, but there's no parameters telling me what's going on over here. And just to make things easy, I'm just going to leave it blank, right? As we approach -4, we approach infinity. So I'm just going to leave it like that. All right, so I'm done with the left side there. As I get to the middle of my graph, I have and I'm looking back through, I have a point at 0, 3, and I have something happening at 1 where the limit does not exist. Okay, so I'm just going to make it a jump again. Find those easiest to do. You could also do a vertical asymptote. That would be correct, but they're just harder to draw. All right, so we do have a point here, and then we're going to approach 1, and we're going to make a jump. So I'm just going to go there, and then I'm going to go and do this. And then I need a removable, so I need a hole, and it doesn't matter where, somewhere along this line that I put in there. So I'll do a hole like that. And then as I approach positive infinity, my y's are approaching, where'd that one go? -1. So I just need to make sure that I'm showing some sort of end behavior occurring here as we approach this. This is just one way to draw this. You certainly could have put a point here and then made a hole here and then approached it that way. There's an infinite number of ways to come up with this, just as long as it fits the parameters that I gave you. All right, so I'm gonna clean this up a little bit because this isn't actually part of the graph. Okay, now that I'm done, I'm gonna look at all this and go, okay, does it meet everything that I just wrote out? All right, so is it a function? Number one, is it a function? Does it pass the vertical line test everywhere? Yes, it does. I'm scanning across and there's no place, even right here, I have a hole and a point and there's no lines going over each other. So that works. -3, 0. -3, 0, that point exists. The limit as x approaches infinity at -1, yep, I do have some end behavior there for positive infinity. Do I have a vertical asymptote at -2? I do. Oops, looks, it's a good thing I went back and checked. I'm approaching it from the left. I'm going up, and I should also be doing this from the right. I did not get that in there. It's good to double check. There we go. I have that now. At 5, is there a removable discontinuity? So 1, 2, 3, 4, 5. There is. A removable discontinuity has to be a hole, and I put that there. The limit of f of x at 1 does not exist. I need to be coming in from 2 different directions. That is occurring. There is a point at 0, 3 right there. And then lastly, I do have an asymptote, vertical asymptote, coming in from the left. I am approaching infinity. All right, I'm pretty sure I did that right. If you see a mistake, let me know. Thanks for hanging in there. I hope this was helpful. Please don't hesitate to email me, or let's set up a office hours or a Google Meet so that way I can help you if you're struggling.